So last time we created some TCP servers. We'll look at that again in a second. But just to review the things we covered yesterday, first we'll do JSON. And we can work with JSON and JavaScript. So we can finish doing this. Does anybody know how we convert something in JavaScript to JSON? Nobody remembers how to do that?
JSON.stringify?
JSON.stringify. I think you give it whatever. So let's say, yeah, let's do that so we can see the difference. Yeah. It takes some other things, but generally just do that. So we'd say, okay, so how do we do that in Go? Well, first we need to make our object, so we have, well, we can do it inside the function the same way. So remember, does anybody remember how we do that? JSON dot Marshall. And then you give it and this returns possibly an error, but otherwise very similar to its JavaScript cousin. Doesn't quite fit on the line here. So how do we do the other direction? So let's add a row. If I have a string and I want to turn it into an object, how do I do that in JavaScript? Use JSON.parse and give it the string. I think that's right. And then over here, we make, so the difference here, we have to give it a type because JavaScript is dynamically typed, so it doesn't, we don't have to do that, but here it's statically typed, so we got to give it a type. But otherwise, very similar, we say JSON.unMarshal. We give it the string and we do a pointer to the object, okay?
It returns an error.
Yeah, it does return an error. So actually, if we wanted to change this, to make this more equivalent, because sometimes people see this and they're like, oh, there's more you have to do here. It's like, well, not actually, because let me show you something. So in JavaScript, where's clear? There it is. What happens if you give it bad JSON? So I say JSON.parse, you know, this is not valid JSON because it's not in quotes. Sorry, that's really small. Let me zoom it in. Okay. So that's not valid JSON because I didn't wrap it in quotes. It's not in curly braces or anything like that. What happens is you get an exception. Syntax error, unexpected token A. So this is a little disingenuous the way we've written the JavaScript here, because this code can throw exceptions. So really the way you should be writing this is with the try catch, okay? And you just say E, and then you do something with, and just to make it look equivalent, we'll call it ERR. So actually, this code is less than this code. So that's a little counterintuitive for people, right? The point is that sort of Go forces you to deal with errors. JavaScript just sort of silently has errors happen. Okay? They're there. You really should be writing them as try catch when you use JSON. But it makes it so you don't have to. And here, it's a little more explicit. You got to deal with it. Okay? Anyway. So that's JSON. Everybody understand JSON? Any questions about JSON? Pretty straightforward. So we spent a bit on that. The next thing we talked about were packages. Does everybody remember how packages work? Anybody want to try and explain? No?
Shin, Nick, Paul.
So
packages are kind of a file structure based. So if you want a new package, you should have a new folder.
Right.
And your folder name should be the name of your package. Is that right?
Yep.
And then every file inside that new folder for your package should be package and then the name of the package, which is the same name as the folder. And then any functions you put in any of the files in that package uppercase letter, they're accessible to the rest of your program outside the package. If they're a lowercase letter, it's a function of the lowercase letter, which is like a helper function that's only accessible within, and this is where I'm not clear, the one file or the files inside the package?
The package. It's package local.
Package
So it's
local.
package. So we saw some examples of that. We had these converters. Notice this package name matches the folder name over here, converters. Okay. We want to write a program that uses it, so we made this distance converter. He starts package main, and he imports it. And notice he uses the full path to it. So this is $go path / source and then / this thing. That's where it's going to look for the code. Okay? And you use it with the converters. Now, if you wanted to, you could rename it. I think I talked about that. Maybe you guys don't remember, but you can say like that, and then you can say it like that. Okay? So you can give your package a different name in the code here if you'd like. But by default, it's going to use this as the name. And usually we just leave it with the full name because it's easier. I didn't show you something that we don't do very often, but sometimes people complain that this is like I have to type this a lot. Wouldn't it be nice if I could just call the function directly? You can do that. You can use a dot here, and now you can just say convert. Sort of like includes it right into here. So everything that was exported in converters is now available inside the program. Generally, you shouldn't do that. It's better to be more explicit, but you can if you want. I'll show you an example of where I found it useful. I think there's a DOM package. There is, good. Okay, so I wrote this DOM package to work with HTML DOMs and Go, and it gets kind of complicated, but it implements like a node and element and all that. And I made this DSL, which is like a domain-specific language, and what I wanted was the shorthand, okay? So I wanted to be able to say E for element, A for attribute, T for text, and so on. And so I could build, I think I have a test in here. I could build, wow, that's a great text. That's bad. I wanted to be able to call, like, E, give it the element tag, you know, like and then I'd say comma, and then A, and then href, you know, whatever. And so, okay, I wanted to be able to do that. That way I could make something that looked kind of like HTML inside my code. Everybody's trying to follow. So this was an example of if I use this library, I'd want to use it with the dot. Because then I don't have to say DSL.E, I can just say E. So it's a lot shorter. But pretty much you shouldn't do that. You should use the full name. But I'm just saying you can if you want. Important. That was it. We didn't talk about it before. What we have talked about is how we can import something without using it. You guys remember how to do that? So if I didn't have this, and I still wanted, what would happen is when I save it gets rid of converters here, because it says imported and not used, right? So exactly, if I want to import it, underscore. Now I'm allowed to import it even though I don't use it. Okay. That's pretty rare to need to do that. So another thing that I didn't talk about with packages, which I meant to, there's a special function we can write in a package that will get run when we import it. Okay, so we have main here. This is in a main package. Remember, this is where a program starts. We have something like main inside of packages that aren't main, and that's init. So I can in here have func init. This function, the special name init, init, gets run whenever the first time this package is imported. So it's generally used to initialize things. Say we had a big table that we wanted to create. We might do it within init, okay? And so just to show how this works, so I'm going to just print out something on init. So if I go to a terminal, exit some of these. Okay, so we go to, where was this guy? Week 2, day 1 converters. Distance converter. So remember, this guy's importing that program. So if I run distance converter, it says I was init. Sorry if that's hard to see, I'll rerun it. So that init function was called when I imported it. But I didn't call it directly. I never said converters.init. Everybody following? Yeah. Init just gets called automatically. So sometimes there is code inside of an init that you want to have happen, even though you don't actually use anything inside of the package. And that's when this becomes useful. Okay. As far as I know, the only place I know where that is actually used is in database SQL. So this, we might talk about SQL later a little more, but the interesting about SQL is sort of a generic, says a generic interface around SQL. So SQL is a protocol, it's a specification to how to interact with databases. And so there's lots of databases that implement SQL. There's PostgreSQL, there's MySQL, there's Microsoft has a SQL server, Oracle is a SQL server. They all implement SQL or variants thereof. And so this is like a package that works with any of them. And the idea is that you'd import SQL, and then in order to connect to the particular SQL that you need, you have to import the driver. So there is a MySQL driver, and the way you would use it, and I think I showed this in here, is you do that. So the basic idea is that I would just be only using the SQL library, but I'm importing the driver to make it so that I can use MySQL. But I'm using the underscore because I don't actually use anything of MySQL, but merely by importing it, I'm making it usable by this library. Okay? So you do sometimes see this underscore import, but pretty rare. Any questions about that? Yeah?
Is init run before or after main?
Before main, and it's like a static constructor kind of, and the idea is that that happens once for the package. So if you have two packages that import the same package, it's only going to happen once. And the ordering is such that if package B depends on package A, A's init will happen before B. B's init. So that turns out to be like a really tricky thing to get right, and it does get it right, but it actually there's a lot of subtlety involved. But just generally think of it, you don't have to worry about it. It does what it's supposed to. And Go doesn't allow you to do cyclical imports, so you should never have a problem with. Yeah, there could be bad things. And the static constructor that can happen, but not with init. Okay, so packages, that's packages, and I just showed you init so that if you need to do that, you can do it with a package. Because we know how to do it with main, we just put it in main, but for things that aren't main, that's how we do the package. And so tests, how do we do tests? If I have a package, how do I test stuff in the package?
You want to create another file with the same name as the file you want to test.
Yep.
And it needs to be like, my file that I want to test is concat.go. I'd have concat_test.go.
Exactly.
Test is capital T.
No, it's all lowercase.
Oh, it's all lowercase? Oh, there we go. And then inside converters test.go, I would have whatever functions I'm wanting to test. I would have that same function name prefixed by capital test.
Yeah, so what it does is it looks for anything that starts with test. And that's how it finds a test. So that you can put anything you want in there. You often just put the name of the function, but you can put anything. And so it takes, remember, T star testing T. And you can go find out more information about that struct in the test and package docs. But basically you use either t.fail or t.arrowf or t.log. And the way we write a test is we just write regular Go code. That Go code uses our function or our package or whatever. And it does stuff, and then we test the results to make sure they do what we expect them to. So in this case, we built table tests, table-driven tests, from to, and then check the results. And if the result matches, then everything's great. If it doesn't match, then we fail the test. It's a test failure. Okay? So what tests give us is the ability to make sure that our code is correct. They also make it so that if in the future somebody changes code, we rerun all the tests to make sure they haven't broken anything. That turns out to be really important for a large team on a large project. It's very hard to know sometimes what happens if I make a small change. Okay? It's hard to predict how a system responds when you change it. Sometimes it's easy, but sometimes it's hard. Tests make it so that you can be a little more confident that you have not broken anything. Okay? So tests are a good part, a good thing, a good practice in software development. Okay, so we talked about tests. Tests are pretty straightforward. I think we get, as we start working on more code, you might get more used to them. And then the final thing we talked about was networking and TCP servers. So how do we create a TCP server in Go? Somebody want to write that in Scratch maybe?
It's net.
Net. So we use
Net dot funk me.
And so what are we doing there? This is Scratch.
All right. Turn my computer on.
So this would, remember this is TCP, and then host name and the port. Now this is a client. Okay, but if we want to create a server, how do we do that? Remember that's listen. So, what's the, somebody want to type that in there? Yeah, there you go. And so, remember the port would be anything you wanted. Though if it's less than, I forget the number, some ports require admin access. I think it's less than 1,000. So, that could be an issue. Well, this won't be, but if you put 80, you'd have to run it as sudo your program. In Linux, there's a special thing you can pass it to make it allow you to use ports without admin access. But just know that if you use a port less than, I think, 1,024, it's going to require admin access to run. But anyway, these don't because they're all greater than that. So, so you do net.listen, TCP, and then the port, and then that gets you a listener. Okay, so what's a listener? What does it have on it? What can we do with a listener?
We get the protocol and the port listen.
Well, we did that. We created a listener. So now we're listening.
Just read and write.
Except, right? So you always have this loop, and you say, right, except, and that gives you a connection. Now, this connection and this connection are basically the same thing. Okay? So at this point, what you do with the connection, there's this sort of mirror image that goes on, right? Now the client and the server are both parties of part of a TCP connection. And so you can do the same thing down here that you do up here with the connection. It's the same. Right? Everybody following that? So this is a reader and a writer. It's just like a file. You can read and write to it. And this is the same thing. So what is missing from these examples? We're not closing them.
Yeah.
And remember, we saw that where if you didn't close the connection, weird things might happen. So it's a good idea to close the connection when you're done. Same goes down here. All right. So we're going to do some more examples of the TCP today. Did anybody do this one? Did anybody finish that? One person? So maybe we should start with that. This creating the simplified Redis clone. Did anybody even get started with it? Okay. And for simplicity here, if you don't want to try to figure it out, you can just make this a single, you can only handle a single request at a time. That's okay. make this easier if you want. We'll see how to take it better, but I just like to see that we can make this basic TCP server that accepts commands and does stuff with it.